We're going to be focusing on square root functions and how shifting is affected by the numbers that we see in the equations. So, kind of get started. They're asking for the square root of -4, and they're asking us why are neither 2 nor -2 the correct square roots of 4. And if you were to put in the square root of 4 on the calculator, square root of -4, you end up getting an error answer. That's the reason why this is true, is because if you square 2 and you square -2, the answers you get out in each case are going to be +4. So, because rules of multiplication, we have a negative times a negative and a positive times a positive for a square. That's the reason why we don't have a negative square root. So, for part B, well, in the case of what we can conclude about that, there are no negative square roots. That give us a real number answer. So, what you'll see on the tables a lot of times with square root functions is you'll see errors in the table. So we're going to look at that in exercise 2 right now. So, for exercise 2, I'm going to go ahead and graph by going to y equals the square root of x. I'm going to press second and graph. I'm going to go to the table. Now, what I talked about earlier, yes, you're going to see some errors. So if I go anywhere in the negative area, I get an error for the y value, which means there's no answer. But I can graph a few of the points that are whole numbers. I got 0, 0, 1, 1. And then moving down, I'm going to skip to ones that are whole numbers. I got 4, 2. And then we also got 9, 3. So I'm going to go ahead and graph those points. So here's 0, 0, 1, 1, 4 to the right, 2 up. And then we got 9 to the right, 3 up. So notice that I drew an arrow on the right side because the graph does keep going. But there is no arrow on the left side because we had those errors. Now the domain for this function is going to be any x value that's greater than or equal to 0. And kind of the same thing with the range. You'll notice that this graph is always increasing as we go to the right, so positive x, and it's always increasing up as we go on the y-axis. So, well, you might notice that this shape, it's half of what? It's half of the parabola or quadratic function. Because again, quadratics have the square in them. So that's kind of the relationship. A square and a square root are opposites of each other. So that's why this graph looks similar to that one. They are inverses. Now, moving on to the back of this, we have talked a little bit about shifting. And you'll see that they graphed already. They graphed the function y equals the square root of x. And that's the one that's included. Now for part A, they want us to do the square root of x plus 4 plus 2. So I'm going to go ahead and I'm going to type that in. And when I do that square root and put the x plus 4 in, I want to make sure that I arrow to the right to get the plus 2 outside of it. Then I'm going to do second and graph to look at my table. And again, you can always change this to mode and go to graph-table. That way you can kind of see both parts of this. So I'm going to go back to the start of that graph. So it looks like right now I have -4, 2 as the first point. Then I got -3, 3. And we got 0, 4. And I'm going to look for one more point on the graph. So I got 5, 5 as well. So 5, 1, 2, 3, 4, 5. Okay. And again, this is going to kind of keep going. It's going to look fairly similar to the one we have. Now they want us to state the domain and range for this function. So you'll notice that the x values, the graph starts and is greater than or equal to -4. Now, there's other ways you can write it. You could also write it like this if you're doing an interval, where x would go from -4 to infinity. So either one of these ways will work. And then with the y values, you look at the y-axis, it's at 2. So y is going to be greater than or equal to 2. Or, like I was just mentioning, you could do 2 in the interval, which would then go up to infinity as well. So what you'll notice with C, they give us another one. They say -1 and -4. So the two parts that would make this true for the table, in this case, I can use my calculator to find that table by typing in, again, it's x -1. And then it's -4 after it. Now, I'm not going to actually go to the table, but I am going to talk about what the domain and range are. So you'll notice that the domain, the x value was opposite that +4, and the y value was the exact value. So I'm going to use that same idea with this, which means that the domain should be x is greater than or equal to 1, and the range should be y values that are greater than or equal to -4. So if I go to the graph and table now, and I go to 1, -4, kind of like I wrote, I can see that that's where the graph starts at, and then it increases to the right and upwards. Now the last one we're going to talk about is an absolute value function, which again, you see those once in a while in the regions, just like a square root function. So they gave us the graph of the absolute value of x, and now they want us to go ahead and graph the absolute value of x plus 3 minus 2. And the same idea like we just talked about. So if you go to math and number, you get ABS, which would be x plus 3 in the parentheses, and then -2 outside. And then if I go to the table, what I want to focus on right now is I want to go to that vertex point where it turns at, which is -3, -2. So for this one, we do have a vertex, a turning point at -3, -2. And you'll notice kind of the same pattern. The x value is opposite and the y value is exact. But for this one, the domain is a little different because the domain is going to be all real values, or all real numbers. And the range is going to be anything greater than -2. So when we do create an absolute value function, it's important to look for that turning point, because that turning point is going to be the key to helping you determine the range of it. Now the domain for most of them is going to be all real numbers, but the range is going to change depending on that vertex point.